Okay, today we're just going to do a bunch of problems out of the book and sort of wrap up our discussion of logarithms. You may recall the basic format for a log is you've got the base here. When there's no base, it's assumed to be 10 and it's called a common log. You have an argument here, and then logs are exponents. So logs equal exponents, and that helps you when you convert to the exponential form. You'll have an easy way of doing that. The base then raised to the exponent equals the argument when it's in exponential form. Now, you cannot have a negative argument, except if you're married, perhaps you can, but none of you is married, so we're going to go ahead and say you cannot have a negative argument. What does that mean for us? Well, what if I have log of x plus 5? I don't show a base, that means it's base 10. And this also means that x plus 5 cannot be negative. It has to be non-negative, and therefore it's going to be x cannot be less than negative 5. So you must keep a positive for your argument. All right, let's do some problems. By the way, when you get a negative argument as an answer, then that means that's a extraneous solution and does not count as a real solution. So you must keep your arguments positive. All right, just remember that. All right, let's take one like this. 3 raised to the x plus 2 minus 5 equals 22. All right, how would I do this? Well, first off, I'd add the 5 to both sides. So I've got 3 to the x plus 2 equals 27. All right, now it's great if I can get both sides of the equation to the same base. Well, 27 I know is 3 cubed. All right, and by knowing that, I've got 3 to the x plus 2 equals 3 cubed. Because these are equal, that means these exponents have to be equal. So x plus 2 equals 3, and x would have to equal 1. Do you see? All right, that's easy enough. What if I had 16 to the x equals 32 to the x minus 1? All right, again, I can solve this by getting to the same base. Well, 16 and 32 are not the same base, but they're both 16 and 32 multiples of 2. So I could replace the 16 with 2 to the 4th. And that's still raised to the x power. And 32 is actually 2 to the 5th. And that's still raised to the x minus 1 power. Now this gets a little bit tricky. This is, we're going to multiply these exponents. This is a power of a power. So 2 to the 4x equals what? 2, and it's 5 times the entire x minus 1. So that's 2. I've got to distribute 5x minus 5. Do you follow? And again, now I have the same base 2. That means that 4x must equal 5x minus 5, which means that 4x equals 5x minus 5, x equals 5. Okay. Do another one. What about 5 to the x equals 1 over 625. Okay, well, remembering my negative exponents, 625 is actually 5, not 5 squared is 25, 5 cubed is 125. That's 5 to the 4th, isn't it? So that's 1 over 5 to the 4th. Well, if I put that back on top, that changes the sign of the exponent. This equals 5 to the negative 4, so x would equal negative 4. All right, these are kind of fun. Let's try another one. What do you mean they're not fun? Yes, they are fun. E to the x equals 3. And I have to solve this for x. This is one of the reasons that logs are still helpful to us. I'm going to convert this to log form. And look what happens when I do that. I've got the base e, so this is actually log base e. All right, logs are exponents. The exponent is x, and the argument is the 3. Well, wait a minute. I've just solved that for x. Do you see how that is? Now you say, well, aren't we supposed to write log e, log base e, a different way? And yes, this could be written natural log 3 equals x. ln natural log. So I would accept either one of these. They both mean the same thing. All right, let's do another one. Let's go to 5 to the x minus 4 equals 135. Uh-oh. Okay, now I've been able to solve all of these without a calculator, but now I'm going to need my calculator. And what I'm going to do here is take the log of each side. So this becomes log of this and log of that. Okay, now I'm going to take my exponent and move it out front. What does this do for me? This is x minus 4 times log 5 equals log 135. Okay, now what am I going to do? Well, that means x minus 4 equals log 135 over log 5. And I can do that in the calculator. All right, now by the way, this also, log 135 divided by log 5 is also log base 5, 135 in your Nspire calculator. The calculator I'm using doesn't have that capability, so I'm going to take the log 135 and divide it by the log 5. And I get 3.05. Now, that's not the x value though, because that's x minus 4. I have to add 4 to that. So the answer to this is 7.05. Because x minus 4 equaled 305. Okay? All right. Doing well. Let's take a look at some new ones. Let's say we had, we talked about on your chart that log x equals, if log x equals log y, that can only be true if x equals y. In other words, you can't have the argument be different on the left side than on the right side and have the two logs still equal each other. That's assuming they have the same base. Okay, so let's do one like this. What if I have log base 2, and that's 5x minus 2, and that's equal to 3. How do I solve that without a calculator? Well, pretty easy. I'm going to convert to exponential form. So that's base 2, exponent, logs are exponents. 3 equals the argument, 5x minus 2. And 2 cubed is 8. So that's 8 equals 5x minus 2. Add 2 to both sides, I get 10 equals 5x. So x equals 2. Well, that's not bad. All right, let's do another one. What if I have log base 3 of 5x plus 3 equals log base 3, and it's 3x plus 11. Okay, well again, I've got two logs that are equal to each other. They're the same base. That means their arguments have to be the same. So 5x plus 3 equals 3x plus 11. Easy cheesy. 2x equals what? 3 away from 11 would be 8. So x equals 4. Now, guys, I do need to check. Would that make either argument negative? No, no. They're both good, so we're fine. All right. Had it made it negative, there would be no solution because you cannot have a negative argument. All right, what about log base 3 x plus 8 equals 2 minus log base 3 x. This is a stumper. I've got logs on both sides, but they're not equal to each other because there's a 2 in there. All right, in this case, what I'm going to do is move this negative log 3x over to the left side, and that makes it division, doesn't it, of the arguments? So this becomes log 3 x plus 8. Excuse me, not division. I take that back because when it moves over, it becomes positive. So that's going to be x plus 8 times x equals 2. Sorry about that. All right, so that's going to be log base 3 x squared plus 8x equals 2. Okay, well, let's convert. Exponential form, that would be the base 3 raised to the log exponent is 2 equals the argument x squared plus 8x. All right, this turns out to be a quadratic equation. 0, 3 squared is 9. I'm going to take that to the other side. Wow, okay, I can factor that. That's going to be x plus 9, x minus 1, isn't it? That means my values are x equals 1 and negative 9. All right, a problem now. Do I have an extraneous root? 1, that'd be log 3 of 9, and that'd be log 3 of 1. That's okay. That works. What about negative 9, though? That would make both of these negative arguments. So this is an extraneous root. The only solution is the 1. You getting it? All right, let's do 2 more. Let's do log base 2 x plus 6 minus log base 2 x equals 3. Okay, good problem. Well, when you subtract logs, that means your arguments are being divided. So this is log base 2 x plus 6 over x equals 3. Let's convert this to the exponential form. That's the base 2 raised to the exponent 3, 2 cubed, equals x plus 6 over x. Oh, Oh, this is not hard. 2 cubed is 8. Multiply both sides by the denominator to get rid of that fraction. So that's 8x equals x plus 6. Okay, that's 7x equals 6, and that's x equals 6/7. Let's check to make sure it's not extraneous. It's positive, so that's okay, and that's okay. There's a good answer. Good problem. Okay, how about one last one? Log base 2 to the x minus log base 2, 5 equals log base 2, 10. Okay, well, subtraction of logs means division, so it's log base 2 x over 5 equals, oh, this is an easy one, log base 2, 10. Okay, these are both logs, they are equal, and that means their arguments has to be equal. So x over 5 equals 10. What am I going to do to solve for x? Multiply both sides by 5. X equals 50. Okay, good luck. Do your homework, worksheets, and show your work where you can. If you're using a calculator, on those that are you're allowed to use a calculator, then make sure you show what it is you're putting into the calculator. Good luck.